Bismillahirrahmanirrahim. The next topic is speed of sound waves. Speed of sound waves. Speed of sound waves. The speed of sound. The speed of sound. The speed of sound is speed of sound is the distance covered by sound waves in a unit time. There are a number of methods for measuring the speed of sound. One of them is given as under. The apparatus used in this experiment is the resonance tube apparatus. Resonance tube apparatus, and particularly this is the resonance tube apparatus. 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 Tuning fork. This is a tuning fork, just a sound producing body. And the rubber pad theory. When a vibrating tuning fork is held horizontally over a resonance tube horizontally held horizontally over a resonance tube, the sound waves will move and the tube. These waves reflect at the close end, that is the surface of water. Here the surface of water. These waves reflect at the close end, that is at the surface of the water, and the tube, starting from a small length of air column, increase its length gradually. You will arrive at situations where the air column increase its length gradually, while where the air column vibrates with the frequency of the tuning fork, the very frequency of this tuning fork, that is for a certain length of the air column, the sound of the tuning fork become loudest, as shown in the figure. At this position is called node and denoted by N. At this position, and this A is the NT node. At this first position, the loudness or certain length of the air column, the sound of the tuning fork become loudest, as shown in the figure. At this position, the air column resonates. With the frequency of the force frequency. Thus, when the frequency of the tuning fork, become equal to the natural frequency of the vibrating air column, the amplitude of the oscillation become maximum, and situation is known as resonance. When a tuning fork vibrates near the edge of the tube, it starts sending the compressional waves. Which are reflected by water surface inside the resonance tube. These reflected waves and incoming waves produce a stationary waves and created a resonance. There will be an NT node at an open ends of the tube. At the open end of the tube, this open end, and at the closed end where the water is present, and the NT node. The tuning fork vibrates near the edge of the tube. It starts sending the compressional waves, which are reflected by water surface inside the resonance tube. These reflected waves and incoming waves produce a stationary waves and create a resonance. There will be an NT node at the open end of the tube and a node at the other end. Since the distance between the node and the next antinode is equal to lambda by 4. The node and antinode is equal to lambda by 4. That is, let's say the distance between this node, this is node and this is the antinode. The distance between this node and antinode is equal to lambda by 2. Lambda by 2. Lambda by 4. Lambda by 4. Lambda 4. Let's say these are stationary waves. These points are called nodal points N1, N1, N2 and N3. These are called nodes. Nodes are the points at which the amplitude is 0, and these are called antinodes A1 and N2. The nodes, antinodes are the points where the amplitude is maximum, and the distance between two consecutive nodes is denoted by lambda by 2, and the distance between this antinode and this nodal point is lambda by 4. 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 We get lambda by 4 is equal to L. So our L is equal to lambda. Lambda is equal to 4L. F is the frequency of the sound tuning fork. And then the sound can be found by using the relation V is equal to F lambda. V is equal to F lambda, because lambda is equal to 4L. So V is equal to F into 4L. V is equal to F, where L is the resonance, the length of the, where lambda is the wavelength of the stationary waves. The stationary wave, the speed of sound in air is from 330 meter per second to 340 meter per second, because speed of sound depends on temperature.